UI Toolkit comes with a lot of built-in controls, but at some point, you may need something specific to your project. And when that happens, you can build your own reusable UI elements. In this video, we'll create a custom visual element and make it show up in UI Builder, ready to drag and drop anywhere. For this demo, we'll build a simple custom control, a SlideToggle. It represents a Boolean value. Think of it like a checkbox, but with a label and a bit of animation. This is a small reusable UI element, a good candidate to make into a custom control. The control has a single value, on or off. Everything else updates based on that state. The label switches between enabled and disabled text. The background color changes to match the state, and the knob slides to a new position. Now let's create the control itself. To make a custom control in UI Toolkit, the class needs to inherit from visual element, and it needs to use the UXMlElement attribute. That tells UI Toolkit to expose it to UXML and make it available in UI Builder. The class also needs to be public so UI Builder can discover it, and partial because Unity generates supporting code behind the scenes. Once we do that, the control appears under Custom Controls in UI Builder. If we drag it into the layout right now, it won't do much yet. It's just an empty visual element, but this gives us a foundation that we'll build on. Let's give it some properties so we can configure it in UI Builder. To expose a property, use the UXML attribute. This makes it appear in the inspector when the element is selected. For this control, we'll define properties for the enabled and disabled states of the text and background color. Each property uses a backing field to store its current value. When you change the value in UI Builder calls the setter, and that keeps the control in sync with what you see in the inspector. Right now, these properties just store values. They don't affect our UI control just yet. We'll use them later to drive the visuals based on the SlideToggle state. At this point, the SlideToggle doesn't have any styling yet, so it's basically invisible. We'll give it a simple default color so we can actually see it while we build it in UI Builder. A good place to do that is in the constructor. The constructor runs when the element is created, so it's where we'll set up any initial values. For now, we'll just assign a temporary background color so the element is visible, and we'll replace it with our full visual logic in a moment. But first, our control doesn't have any state yet, so let's fix that. So far, our SlideToggle is still just a colored visual element, but a toggle is really a field. It represents a value either on or off. We could build all of this behavior ourselves, but we don't need to. UI Toolkit already has a base class for controls that represent values, and that class is BaseField. BaseField actually inherits from visual element, so we're still working with the same underlying UI system, just with more built-in behavior. It's also a generic class, so we'll use bool as the type. And that means that this control stores a Boolean value, true or false, on or off. By inheriting from BaseField, our control gets a lot for free. It already gives us a value property, built-in change events, data binding support, and a label. So we don't need to rebuild any of that ourselves. And this is usually the right base class when your control represents data. Now, if it doesn't, you can stick with a plain visual element. There's one important difference. When we inherit from BaseField, it has its own constructor, so we need to call that from our control. This constructor takes two parameters, a label string and an input element. We'll pass null for the label string, which means it will start out empty on purpose. You won't see any label text at first. Then we create a new visual element to act as the input container. That part represents the field. And we still keep a constructor without parameters because that's what UXML expects when we create an element in UI Builder. So we're just forwarding some default values to the base constructor, and that gives us a clean structure that we'll use to build our SlideToggle. Now let's build the internal structure of the control. Because SlideToggle inherits from BaseField, it already comes with some built-in UI that includes a label and an input container. So instead of creating everything from scratch, we can build on top of what BaseField already gives us. First, we define a few USS class names. We'll use these as hooks for styling the SlideToggle and its parts. The BEM naming keeps everything easier to maintain. The block is the slide toggle. The element is the input or input knob. And in this case, the input can be modified into a checked or on state. We can store references to the elements that represent the input and the knob. Now let's go back to the constructor and rebuild the structure. Clear out our temp color, we'll re-add visuals later, and add our custom slide toggle class to the root element. Next, we grab the built-in input container. Then we add our own class so we can style it later. And now we create the knob. This is just a visual element with its own class, and we can add it as a child of the input. At this point, the structure is complete. BaseField already gives us the label element, the input container, and the value. We're just adding one extra element, the knob, to represent the toggle visually. Right now, it doesn't do anything yet, but we have the structure we need to style and animate it like a real slide toggle. Now let's make the control interactive. We register a click callback in the constructor on the root element so that the entire control is clickable. When the user clicks, we just flip the value from true to false, or vice versa. And this is one of the main benefits of inheriting from BaseField. We're not managing state ourselves, we're using the built-in value property. When you change this value, UI Toolkit handles all the rest. It updates the field, sends a change event, and supports data binding if you're using it. We want the act of clicking to change the state first, and then the visuals will respond to that state. To update the visuals, we'll add another method called updateVisuals, and this takes the current true-false value and then translates it into the correct colors, text, and layout. We'll also call it once in the constructor, so the control starts in the correct visual state. When the value is on, we add a check class to the input element, and that class drives the animation. It moves the knob into the on position. We also update the background color to reflect the enabled state. And since BaseField already gives us a label, we update the text to show whether the toggle is on or off. So the value represents the state, and the updateVisuals method turns that state into something that you can see. And now we want to make sure that this runs whenever the value changes. A good place to do that is a method called setValueWithoutNotify. BaseField already uses this method to assign the value, so we override it, call the base version, and then refresh the visuals. Now this keeps the control in sync no matter how the value changes. It doesn't matter if it's from a click, script logic, or from data binding. And we'll also want to update the values when the attributes change. So right now, the setters just store values. They don't affect the UI yet. So we'll add a call to update visuals in each setter like this. And now whenever the text or colors change in UI Builder or at runtime, the control updates immediately as well. Now let's style the control in USS. At this point, we've already assigned our USS class names in C#. Now we need to define how everything looks. You'll probably build most of this interactively in UI Builder, but here's a simple style sheet for a working slide toggle. Nothing fancy here, just the input track, a knob, and a check state. First, the root element fills the available space. Next, the input becomes the track. We give it a size, round the corners, and add a border so it stands out. We also add a transition so the color changes animate smoothly. And then we define the style properties for the knob. This is just a circular visual element with a large border radius, positioned inside the input. When the check class is active, we translate the knob to the other side. Combined with the transition, that's what creates the sliding motion. Notice that we're not setting the background color here for the input, and that's because we're already controlling it from C# using our attributes. We can also style the label since BaseField gives us one automatically. We just target the Unity label to adjust the font size and alignment. So C# controls the state and any dynamic styling, and USS handles the layout and animation. And now we have a control that we can drop in anywhere. In UI Builder, add the USS style sheet to the UXML. Place the slide toggle in the layout if you haven't already. Select it, and the inspector shows the properties that we expose with UXML attribute. BaseField already includes a label, but since it starts empty, you won't see it right away. Just type something into the label field to make it visible, and then adjust the text and color attributes to customize the slide toggle. Enter preview mode, and you can see how it looks at runtime. And this is really the payoff for building a custom control. We define the structure and behavior once in C#, and then you or your future self can reuse it whenever you need it. So instead of rebuilding the same toggle each time, we now have a reusable component that we can drop into any UI. At runtime, you'll still use a C# script to control the slide toggle's behavior, just like any other control. For example, let's suppose you wanted to use the slide toggle to mute the sound effects or music. You might make a component like this to use our custom slide toggle, query it from the visual tree, set its initial value, and then register a callback. Because it derives from BaseField, it already supports value change events. So when the value changes, you can respond to it in your own code. Here we're just logging the result, but this is where you'd hook into your audio system or other game logic. Once you're comfortable creating custom controls, you can start tackling more advanced UI. In the QuizU project, we used the same approach to build a radial progress bar, perfect for something like a circular health bar or a speedometer. It's more complex visually, but the structure is essentially the same. Define some attributes and properties, update state in C#, and then let USS handle the visuals. Combined with the Vector API in Painter 2D, you can start building your own library of unique controls designed just for your application. Start small with something like this toggle, and then build up from there. If you want to learn more, check the links in the description, and take a look at the official UI Toolkit documentation. Thanks for watching.